Welcome, everyone, and thank you for joining us today. Our focus in this session is one of the most pressing challenges organizations face, as Paige mentioned, and that is how to truly know every customer and resolve every identity. So we'll explore how graph technology addresses these challenges head on, helping organization unify fragmented data, resolve inconsistencies, and uncover hidden connections. But most importantly, we'll see how graph-powered entity resolution not only strengthens compliance and reduces risks, but also enables richer, more personalized customer experiences. My name is Sebastian Mansell. I'm a Senior Director of Product Management here at TigerGraph. I head our Savannah Cloud product offering, which brings together the power of graph technology and the scalability of the cloud to tackle some of the toughest data challenges organizations face today. So each year, billions of dollars are laundered or lost to fraud, and millions of customers are frustrated by poor identity verification. At the root of all these challenges lies one common issue: the ability to accurately resolve identities and truly know who's who. And so in today's webinars, we'll walk through three parts. First, why entity resolution matters, defining what it is, why it's critical, and the impact it has on banks, businesses, and individuals. How entity resolution is done today, where we'll be exploring current methodologies and some of their limitations, and why graph changes the game, showing how graph technology enhances these approaches to deliver measurable improvements in accuracy, compliance, fraud prevention, but also customer experience. So what is entity resolution? Well, entity resolution is the process of identifying and linking records that refer to the same real-world entity, such as a person, a business, or a product. And even when those records exist across different systems, or when they use different formats or contain inconsistencies like typos, alternate spellings, or missing data. Now, why is this important? Well, entity resolution addresses three core data challenges. One is duplicate records, where we have multiple records for the same individual or organization, which creates noise. The second is data fragmentation, where data is siloed in CRM systems, in billing platforms, in support databases, or contains partial information. And the third is inconsistent or incomplete data. And real-world data we know is messy. It's hard to accurately match records when there are variations in formatting or errors in the data. And here's where entity resolution steps in. It matches and merges duplicates into a single trusted record. It links fragmented records across systems to provide a unified view of an entity. It handles inconsistency through data standardization, probabilistic matching techniques, and increasingly AI and machine learning models that improve accuracy over time. And ultimately, entity resolution transforms messy, disconnected records into accurate, actionable views of real-world entities. So when we think about entity resolution and why it matters, it comes down to four core challenges. The first one is record keeping. Legacy systems, siloed platforms, and mergers often leave organizations with duplicate or incomplete customer records. Poor data quality slows down know your customer, compliance checks, and fraud monitoring. And that creates also frustration for customers. The second is compliance. Inconsistent or missing KYC data leads to false positives in sanctions and screening, as well as blind spots in AML monitoring. Having a single unified source of truth improves accuracy, auditability, and SLA performance. Then there's fraud prevention. Fragmented identities give fraudsters cover, letting them open fake accounts, run up credit, or move money across channels without detections. And by linking accounts, devices, and IPs, organizations can spot multi-hop fraud networks early. Finally, personalization. Fragmented data prevents a complete customer view, leading to slow onboarding and disconnected experiences. Unified entities allow for more relevant cross-sell and upsell opportunities without re-verifying the same customer over and over. So entity resolution isn't just about clean data. It directly supports compliance, it protects against fraud, and it improves the customer experience. So let's take a look at the scale of the problem and the opportunity around entity resolution. So when we talk about know your customer, most people immediately think of compliance. And it's true, KYC is a regulatory requirement. But what is often missed is that KYC has enormous value beyond compliance. Salesforce shows that better identity resolution and KYC processes drive a 25% improvement in customer retention. And Accenture found that 80% of customers value personalized experiences, which are only possible if your records are clean, consistent, and connected. So KYC isn't just about satisfying regulators. It's also about keeping customers, delivering personalization, and ensuring good record keeping that underpins every part of your business. Now, on the fraud side, Experian reports that strong identity verification reduces fraud losses by 45%. And the digital ID verification market is predicted to hit $40 billion by 2027. So this is becoming a very big topic. And finally, anti-money laundering. Globally, $2 trillion is laundered each year. And banks spend 270 billion annually to try to stop it. So these are staggering numbers. But yet, gaps in entity resolution continue to create risk. So the bottom line is, entity resolution is not just a compliance task, it's the foundation of customer experience, fraud prevention, and anti-money laundering. All right, so let's take a real-world example. Let's take a look at a real-world example of what happens when entity resolution and AML monitoring fail at scale. Between 2007 and 2015, Danske Bank laundered over 800 billion euros through its Estonian branch. Now, the fallout was massive. In 2022, the US Department of Justice imposed a $2 billion fine, the largest AML penalty in Europe at the time. But the fine was only part of the story. The bank's stock price dropped by 50%, and reputational damage lasted for years. Trust was broken with regulators, customers, and investors alike. And Danske is not alone. Just last year, the DOJ fined another major bank $3 billion for AML-related lapses. So these cases show us the cost of failing to connect the dots across entities and transactions. So again, it's not just about compliance risk. It's an existential business risk. And this raises an important question, is why do today's method for entity resolution fall short? Well, when it comes to entity resolutions, there are three core methods: deterministic, probabilistic, and machine learning. Now, each plays an important role, and in practice, they're often used together. But each also has its own set of limitations, and that's exactly where Graph comes in. Graph doesn't replace these approaches, it strengthens them, adding the context, flexibility, and the accuracy. So looking at each method, deterministic is the simplest, most straightforward. It's exact field-to-field matching. If a social security numbers match, or if a name and date of birth match, you assume that these records is for the same person. It's precise but brittle. It misses variations like typos, nicknames, and address changes. And Graph strengthens this by enabling multi-hop matching and transitivity. So if A matches B and B matches C, we can infer that A also matches C, leading to a more complete identity resolution. The probabilistic approach takes a different angle. It uses similarity scores. Maybe two addresses are 90% similar, or two names look alike. And this flexibility helps catch near matches, but it's limited to pairwise comparison and can create false positive at scale. Graph enhances probabilistic methods by adding context. It considers neighbors, patterns, and behaviors, and it reduces false positives and improves accuracy. And finally, we have machine learning, which is more adaptive. It can learn from many attributes at once, but flat attribute models often lack the context and can be opaque as well. So Graph enriches machine learning by adding structural features, neighbors, paths, communities, which make models richer, more accurate, and more explainable. So the point here is not to pick just one method. It's that deterministic, probabilistic, and machine learning each address different aspects of the problem. And together, enhanced with Graph, they provide the most complete and reliable entity resolution. All right, so this slide takes us a level deeper into how deterministic matching works and when enhanced, and how Graph can enhance it. On the left-hand side, you see three different source systems. One has Social Security, email, and address. Another has Social Security, phone, name, and age. And a third has email, phone, and gender. So individually, none of these sources give you the full customer picture. Now, in the middle, we map these relational sources into a graph. The graph connects attributes like phone, Social Security, and email to individual vertices. And you notice how the same Social Security links one record to another, while email or phone provide additional bridges. And then on the right-hand side, the graph consolidates and merges these attributes into a unified customer entity. Conflicting values like multiple addresses or ages can be handled with governance rules, such as taking the most recent or storing both for transparency. So let's think of a real-world example. Imagine a bank retail division has a record with customer Social Security and address. The wealth management division has the same Social Security with a phone number and date of birth. Meanwhile, the credit card system only has the customer's email and phone. So in a table world, these remain as three separate records. But in a graph, those fields all connect back, and we can see they represent the same individual. So the key point is this: deterministic matching in a graph is not limited to single field-to-field lookups. Graph lets us combine attributes across sources, use multi-hop connections, and resolve identities into a single, more accurate entity profile. Now let's move on to the probabilistic matching. Unlike deterministic rules, here we allow for uncertainty. Entities can look alike without being identical. So for example, Barry Merkham and Beryl Merkham may not be an exact match, but they could still represent the same person. So on this slide, you see unconnected entities, just dots with no relationships yet. At this stage, we don't know how likely they are to match. The probabilistic method evaluates similarity across attributes like name, email, or phone, and even behavior. Now, these weak signals don't prove a match on their own, but when we combine them, we start to see clusters, groups of records that are likely to represent the same individual. So here we see how probabilistic scoring works in practice. Each line represents a similarity score between two entities. For example, A and D have a 0.95 similarity, meaning that they're almost certainly the same. But C and E only share a weaker 0.65 similarity. So maybe they look alike, but not enough to conclude that they're the same. Different algorithms can be applied here: Jacquard similarity, cosine similarity, and others, each producing a score that tells us how close these two records are. The key point is that probabilistic methods don't just say match or no match. They let us quantify uncertainty, capturing the near misses and fuzzy matches that deterministic rules would ignore. Okay, now that we've taken those similarity scores and start clustering them, patterns emerge. So on the left-hand side, we see a group of entities with very high similarity to one another. On the right-hand side, another smaller cluster forms. These clusters represent different individuals. And this is where probabilistic methods shine, catching subtle variations and connecting records that almost, but not exactly, are the same. So for example, one cluster might represent Barry Markham and the other cluster Beryl Markham. A deterministic system might have missed those connections, but probabilistic scoring let us recognize and group them appropriately. All right, now let's look at machine learning in the context of entity resolution. So the first step on the left-hand side is representing data as a graph. Instead of treating each record as a flat row of attributes, we capture the connections. Who shares addresses, emails, phone numbers, or transactions. From that graph, we can generate features for ML models. These aren't just raw attributes like name or date of birth, but structural features, similarity scores, shared neighbors, and paths between records. Now, once we have these features, we can feed them into models like XGBoost or even a graph neural network. And these models, they learn patterns across the data and predict whether two records represent the same entity. On the right-hand side, you see the outcome, clustering records together. For example, A and B are predicted to be the same person, John Smith, while C is recognized as a separate entity, J Smith. Now, the key point here is that graph gives machine learning much, much richer input data. Instead of relying only on isolated attributes, the model sees the network context, which makes it both more accurate and more explainable. All right, so now you've resolved entities. The next step is linking these records together. And there's a few approaches to do this, depending really on your use case. So on the left-hand side, we have matching links. So this is the simplest approach. Records are linked directly through shared attributes, like two customers tied to the same phone number or address. These records remain distinct, but connected for analysis. And this approach works well in AML monitoring, where you often see the full network of connections without collapsing the data. Now in the middle, we see unified entity vertex. Here, we create a new node that represents the consolidated entity. All related records and attributes point to that unified vertex. Now, this is useful for customer 360 or KYC use cases, where you want a golden record for each customer, but you still want to preserve links back to the source systems. On the right-hand side is merged entity. Now, in this approach, overlapping records are collapsed into one, with attributes merged together. Now, this gives you a streamlined view, which is effective for operational systems or downstream applications that need clean, deduplicated data for transactions. Now, the key takeaway here is that Graph doesn't force you into a single model. It gives you the flexibility to choose the right strategy based on your business needs. Now, whether that's investigating networks, building a unified profile, or simplifying operational data. But the real question is, what does this look like in practice? How are organizations actually using these capabilities to solve their toughest identity and compliance challenges? So let's shift from the technical view to real-world example, customer success stories that show how TigerGraph-powered entity resolution helps fraud detection, improve compliance, and deliver better experiences. So we're going to start with Nubank. And Nubank's story is a great example of how entity resolution powers fraud prevention. The bank faced 72,000 fraud cases, with new fraud patterns constantly emerging. Now, legacy predictive models struggled. They could only look at isolated attributes, which led to low precision, high false positives, and frustrated customers. Now, with TigerGraph, the breakthrough came from resolving entities across accounts, devices, and transactions. By connecting signals like shared phones, emails, and transaction behaviors, they could see the full context of a customer or fraud ring, not just individual records. That entity resolution foundation allowed their fraud models to run faster and more accurately. The result? 3 times more transactions screened per second, and at the same time, 3x reduction in false positive. So the lesson here is that fraud detection isn't just about better algorithms. It's also about having the right entity resolution in place to give those models the context they need. Now, the next example comes from the digital identity verification space, where identity or identity resolution is absolutely central. The challenge here is twofold. First, enterprises face increasing threats from fraudsters exploiting digital channels. That's a pervasive problem. Second, identity verification processes are often manual and fragmented, leading to inefficiencies, higher risk, and poor user experiences. And of course, KYC and ML compliance demand and require strong, adaptable solutions. So by applying TigerGraph, this provider can connect and resolve identities across documents, devices, and accounts to deliver a unified, trusted view of each customer. And that means better fraud prevention, smoother onboarding, and stronger compliance. And the results are striking. Up to 80% fraud reduction, 10 to 30% higher conversion rates, and 50 to 70% improvements in operational efficiency. Now, the key point here is that entity resolution isn't just about meeting compliance checks. It's about creating frictionless, trustworthy experiences for customers while driving efficiency at scale. All right, so now that we've seen the impact of the impact that entity resolution can have, let's shift gears a little bit and look at how this actually comes to life in TigerGraph. So this slide shows an example of what an operational dashboard can look like when powered by TigerGraph. And the purpose isn't just to resolve entities, right? It's to provide visibility and measurable outcomes. And a dashboard like this illustrates the kind of metrics and insights that our customers track every day. So you can see the basics, like number of records processed and duplicate records resolved, but also the business impact, right, which is represented as dollar savings. Below the dashboard highlights and the KPIs, some of the most relevant operational insights are laid out, such as how much redundancy was eliminated, where conflicting data fields still need review, and whether watchlist screenings are up to date. Now, the takeaway here is that TigerGraph doesn't just resolve data in the background, it makes the entire process transparent, measurable, and auditable. And that's essential for compliance, efficiency, but ultimately also trust. So here we're looking at a compliance-focused dashboard. Now, that's another example of how TigerGraph provides not just entity resolution, but actionable oversight for regulatory requirements. At the top of you'll see the KPIs, alerts, escalated cases, and again, the dollar value of fines avoided. Below that, metrics like KYC completeness, reporting accuracy, and time to investigation show how effectively teams are meeting regulatory expectations. Now, other panels further down highlight trends, escalation rates, and root causes such as KYC exceptions, structuring attempts, and high-risk geographies. So here, the key takeaway is compliance isn't just about spotting suspicious activity. It's about speed. It's about visibility and getting the evidence to satisfy the regulators and protect the institutions. Okay, so in this example, this is more of a fraud-focused dashboard powered by TigerGraph. The goal isn't just, again, to flag suspicious transaction. It's to provide actionable insights that fraud teams can act on quickly. At the top, you see the key KPIs, the number of incidents flagged, total transactional amount at risk, people of interest identified, and transactions currently under review. Now, these metrics give leaders a clear view of exposure and scale. Now, looking deeper into the dashboard, we see fraud broken down into categories like application fraud, account takeover, or a synthetic identity fraud. We also see true versus false positive, which is really critical for reducing wasted investigation efforts. Now, the dashboard also highlights network level patterns. So, for example, fraud rings detected, 77 in this case, and shows how Graph connects the dots across accounts, devices, and transactions to uncover hidden groups working together. All right, now let's explore graphs, the actual graphs and the queries that are built into TigerGraph. One of the advantages of our cloud offering is that it comes complete with 9 pre-built solution kits. Each has data, schemas, and queries that help teams get started quickly. 2 of those solution kits, I'm happy to say, focus specifically on entity resolution. So that makes it easy to experiment with different approaches and see results right away. So in this instance, I've got my workspace and I've already loaded the entity resolution solution kit. And what I'll do is I'll navigate directly into the graph schema where we'll do a deep dive into how entity resolution is modeled and how it's executed in TigerGraph. So here's our schema. And as you can clearly see, the purple dot here, the core vertex is the party. So what the party is, it represents the individual or entity we're trying to resolve. And the goal is to identify parties with similar personally identifiable information, PII, to support accurate KYC. The schema includes connections from party to attributes such as date of birth, ID, email, phone number, and name. And you can see all these are connected by edges back to our core vertex. Now, one important feature of this kit is that it supports incremental and online entity resolution. So what this means is that organization can continuously update and maintain accurate customer records. Now we've included pre-built queries to demonstrate also that organization can keep customer information clean while reducing fraud and regulatory risk. And that's where we're going to go next. So what we're looking at here is the GSQL query that powers the match party entities operation in the entity resolution solution kit. So this looks complicated, but what it really does is it's a query that applies weights to different attributes. So for example, full name, date of birth, email, phone number, address, ID, and devices. Those are all attributes, and each is given a relative importance in the matching process. And that's really key, right? Because if you have an exact ID match, that's going to likely carry more weight than a partial address match, right? So in this, you have the flexibility in TigerGraph to really tune your matching logic based on your business requirements. And that's what our customers do day in, day out. So what the query does is it calculates a similarity score between the parties. If the score exceeds a defined threshold, a similarity edge, again, that's a link, is created, effectively saying these 2 records likely represent the same person. It also includes rules for scalability. So for example, you can limit the maximum degree of attributes to avoid noisy connections and allow incremental matching by date. So what's really powerful here is that you don't just see the raw query. It is that it's a configurable framework. That's really how you should think about this. So analysts can adjust the thresholds, they can tweak the weights and define which attributes are included without having to rewrite everything from scratch. So the key takeaway here is that the query is the engine that operationalizes entity resolution. It combines deterministic matches like IDs with probabilistic ones like partial names and addresses, all within the context of the graph. So once we open the query, just to give you an example, all right, you can see that the parameters that drive how similarity is calculated. You can see those parameters on the right-hand side. And each attribute is assigned a weight. That reflects its importance in determining a match. So again, if you have, let's say, a driver's license ID, a device ID, or an account ID, those can have weights of 1, which means that they're really strong identifiers that would heavily influence whether two parties are considered the same. On the other hand, full name, date of birth, email, phone number, addresses have a lower weight of 0.2. So these attributes may be useful, but they're not as definitive on matching records on their own. So the key takeaway here is that the ability to configure attribute weights means entity resolution is not one size fits all. Instead, it's adaptable, allowing you to tailor matching to your specific risk, compliance, or customer experience priorities. All right, so in this slide, the output, what this slide shows is really the output of entity resolution query. So here the system is counting how many matched entities pairs were found. In this case, 127. Along the count, we're also capturing key quality metrics, the average, the minimum, and maximum match scores. Now, this is important because it's not just about finding duplicates or related records. It's about understanding the confidence level of those matches. A higher score means stronger alignment across attributes, while a lower score signals potential edge cases that may need review. And notice the execution time, just 12 seconds. That's the power of graph, delivering fast, explainable result at scale. All right, so we've covered a lot in this session. So let's recap some of the benefits of using graphs. So graph naturally connects fragmented or duplicate records, making it ideal for entity resolution. Multi-hop traversal uncovers hidden links like shared devices or addresses across different profiles. And it delivers real-time resolution at scale. That's critical for onboarding and fraud checks. Graph also supports in-database similarity scoring and ML integration, and that improves match accuracy and reduces false positive. All right, so now what are the benefits of using TigerGraph? Well, entity resolution is about connecting the dots across fragmented and sometimes messy data. So with TigerGraph, you can do deep multi-hop reasoning. So this is it follows the chain of connections across multiple attributes like phone, address, device to uncover hidden links between records. And TigerGraph is really built for scale and speed. This is one of our key differentiator here. So deduplication and matching can run across millions of records in real time, whether it's during onboarding or fraud checks. And TigerGraph supports ML-enhanced resolution. So it combines fuzzy logic, graph features, and machine learning to reduce false positive and make matches more accurate. And with its flexible query language, GSQL, organizations can define their own matching rules. And this is really key, right? Organizations want to be able to adjust the weights and thresholds and even run incremental updates without restarting the whole process. So the bottom line is TigerGraph doesn't replace deterministic, probabilistic, or ML methods. It strengthens them. It makes entity resolution faster, more accurate, and more scalable in production. All right, and that concludes our webinar.